Welcome to the fifth slide session of Principles of Industrial Engineering. So we will be talking about the material handling related aspects. As we know, during the manufacturing, it is required that material from its raw condition to the semi-finished condition to the finished condition needs to be transferred. So these are different stages through which material will be passing through in course of the production process. So since the material is processed at different stages, so it is required that it moves from one stage to another step. So we will be discussing questions on this topic now. Movement and relative logistics. So first we'll understand that the amount of the material to be moved, the material to be moved once in a while, or it is like so once or twice in a day, then continuous movement is needed. So accordingly, the suitable kind of the material handling equipment should be used. The nature of movement is about whether it is continuous or intermittent kind of movement. Like fixed roller conveyors and conveyors can be used for continuous movement. Likewise, the monorails can be used for continuous movement. Industrial tucks and the hoist can be used for intermittent movement. So, according to this, the continuous movement are used for fixed rollers, conveyors, intermittent movements are done using industrial trucks. So, according to the amount of material and hoist and whether material to be moved once in a while or once or twice in a day, material handling equipment should be used. So the correct option is roller or belt conveyor are used for the continuous movement and relatively large distance. Okay, so the next question is material handling system used in the dam for facilitating opening and closing of the water flow is C. Hoisting machine is for release or control of water. So this is the correct option. In industries, electrical or chain hoist is used. That is fixed path, fixed distance, and no change in direction. Now these chutes, which we know, these are used for fixed path material handling system. They use the gravity or effect of gravity to move the material from one point to the second point thus This case mostly movement of material over short distance in a fixed path or fixed direction. Now we'll also discuss a little bit about this forklift. Forklift is an electrical powered vehicle. So forklift, this is a electric powered vehicle. This may be of fork type or platform type. So this is used in industries to move the material from one section or one department to another. Okay, so we discussed what is a hoisting machine, what's a forklift, what is a tube. So this was about the material handling system. Next is production planning involves which of the following? Crashing of the network, arranging of the resources to required output, dispatching of the product, all of the above. Well, this is in terms of quantity, quality, cost, and time. So, production planning and production control this in totality helps in developing the suitable plans in such a way that required resources are arranged and required resources are arranged and using those resources the things are produced in such a way that they are of required quality quantity. So the organization can provide the quality products to their customers at a very competitive price. This is about production planning. So the correct option is arranging the resources to achieve required output. Now control is it ensures to the progress, checking, expediting and taking the corrective action accordingly, like adding more resources, changing the plan, making or taking the decision about buying from some other source or giving the contract for delivery of the items to some other. Okay. So here I would like to add that things are produced in time and that too at a low cost. So main aim is the organization can provide the quality products to their customers at very competitive price. Okay. So the next question. Production control ensures that, as we know, the correct option is required output can be achieved on time. So production control, it ensures all of the above. So production control ensures through the progress checking, expediting and taking the corrective action accordingly, like adding more resources, changing the plan, making or taking the decision about buying from some other source or giving the contract for delivery of the items to some other. Okay, so here, as we know, the production control, it is basically production planning and control is a tool available for the management of the particular organization which helps in realizing the goals and objectives related with the production of the goods and services in which they are. So it helps the organization to come out with the goods and the services using a production system in such a way that the organization is able to produce the goods and services of the required quality in required quantity and at required correct right time. Okay, so the next question is flow of the work and material in the production process is termed as, this is known as routing. So there are routing is different stages through which it will be passing. So what will be the different paths it will be following that will depend upon the layout of the facilities. So there are three phases. there is an action, this like dispatching, production planning, and this is the action phase. In the action phase, we have production control. This here, prior planning and active planning phase. So action phase, commencement of production takes place. Action phase, commencement of production takes place. Now production control looks into the progress and identifies if there is any deviation from the planned production. Okay, so in production control, this looks into the progress and identifies if there is any deviation from the planned production. So, in dispatching, relevant orders are given, like to the shop floor to the start the production. So here I am also discussing on what happens in dispatching, what happens in scheduling, what happens in routing, what happens in expediting. So first we understood what happens in dispatching. Okay, next is we are understanding what happens in scheduling. Scheduling is time when particular work will be started and finished. This is the sequence in which operations will be done so that it will be completed on time. Now, expediting means this is scheduling, this is routing. Now, we will discuss about expediting. Expediting means close observation of the execution. Basically, it involves the follow-up, that is current status at any time, which will help us in identifying the bottleneck in production section. Bottleneck means delay in production system. Now, after identifying this, the bottleneck in the production system. Suitable efforts can be made to avoid or reduce any such kind of bottleneck. So this was all about scheduling, expediting, routing, dispatching. Okay, so moving to the next question. Now, aggregate planning is concerned with determining the quantity and timing of production in the which of them? Short term, long term, next term, intermediate term. The correct option is intermediate term. This is approximately 3 months to 12 months of time now. This is the intermediate kind of planning which is done for like period of 3 to 12 months. So when the number of components are being produced or subcomponents are being produced, what will be all components that will be needed and what will how they will be identified in this stage. So this happens in this type of in aggregate planning. So here planning of quantity and timing is identified when the different units or subcomponents will be needed. It also identifies the demand, how that will be met, fluctuation in demand, and how it will be met through labor adjustments or inventory. Eventually, the advantages of aggregate planning is this helps in minimizing the cost, helps in minimizing the cost, input for production system, identifying the kind of labor material or capital which will be needed for a smooth production. Okay, so the next question is inventory level increases unnecessarily when. Okay, so the inventory higher production capacity and less demand will be leading to unnecessary building of inventory. Holding up of the cost and capital will occur, which is also not good. So in both these situations, the profit will be reduced. So it is important that whatever is the capacity of the plant should be almost equal to the level of the demand capacity. It should match with the demand level so that maximum plant capacity is utilized and whatever is the demand, it is also fulfilled. So the correct option is option B. This will lead to higher plant capacity and low demand, which will lead to unnecessary building up of the inventory holding up of the cost and capital profit will be reduced. Moving to the next question. Correct statement with reference to the capacity plan. Capacity planning seeks to match demand to available sources. It examines what systems are in place, measures their performance, and determines patterns in usage that enables the planner to predict demand, resources, and provision and allocate to meet demand all of those. The correct option is all of those. In capacity planning, we try to plan out the infrastructure in such a way that the demand of the customers can be realized or achieved so that required items can be supplied to the customers on time in required quantity and quality and required quality. Okay, so this was about the capacity planning. So the capacity planning, it is a suitable system, whether it is using the batch production approach or mass production approach. Now the suitable production system has to be designed so whatever output it is giving, that should be capable to meet the demand of the customers in required quality, quantity, characteristics, and also cost. This is about the capacity planning. So resources and provision and allocate to meet demand. In measures their performance, determines in usage that enables the planner to predict demand, seeks to match demand to available sources. Okay. So the next question is characteristics features which promotes the short product life cycle are uncertainty of technological advancement, high reliability, product expansion, all of the above. So short product life cycles, these are mostly affected due to fast changing technologies, new features, new technologies. So here what happens is in the product life cycle, whether the product achieves the maturity in 5. So the correct option is characteristic features which promotes the short product life cycle is uncertainty of technological advancement. That means the uncertainty, the fast changing, this is due to the fast changing technologies, new features, and the new technologies. So the product in this product cycle, whether the product achieves the maturity in 5 years or in just 2 years and thereafter decline starts in that demand. Now what is happening is because of these fast changing technologies, newer features, and the newer technologies which are coming up, this leads to this short product life cycle, which is making the long term capacity. This makes long term capacity planning strategy is more difficult. More difficult. Okay. So this was about the short product life cycle. Next question. In a plant, design capacity, system capacity, actual capacity are 500, 450, 400 units respectively. Then the plant utilization will be. So in this question, first we will understand what is a design capacity, system capacity, and actual capacity. So design capacity is engineered capacity, kind of like which has machines, kind of machines or manpower or system which has been established considering some maximum output expected from it. Now, system capacity means, this means whatever output has been designed in form of the production system. Actual capacity, this is lower than what the system can produce and is dependent on short term. So this actual capacity, this is lower than what the system can produce and is dependent, can produce and is dependent on short term factors like machine breakdown. So now plant utilization is equal to actual output by design capacity. So here in this question, actual output is 400 and design capacity is 500. So plant utilization is 400 by 500 is equal to 0.8 is equal to 80%. The correct answer is C, 80%. So that means plant utilization is actual output by design capacity. So design capacity means engineered capacity, like kind of machines or manpower system which has been established considering the maximum output expected from it. That is why it is 500, and the actual capacity is always lower than what the system can produce and is dependent on short term factors like machine breakdown. So that is why it is the least, that is 400. Okay, so the next question is, an assembly of equipment involves the tasks A to N, precedence tasks and processing time of this task in minutes are given in the following table. Considering cycle time of 20 minutes at any workstation, balance the assembly line and find the optimum number of workstations. Also find the idle time at each workstation. So this is the assembly line question. So here first we will draw the our task. So first we will draw our task assembly line. So here the predecessor is A, B, C. They don't have any predecessor. So this will be A, B, C. Now D, E, F are, they have the predecessors A, B, C. So we will just write D, E, F. Now G has the D as predecessor. So this is G. And H has E and I has F. Now J has G as predecessor and K has I and L has J and H. So we will connect J and H and draw L coming from it. M has K and N has L and M. Arrow mark gives the direction for these balanced activities. Now we will group them as per the workstation and element time. Okay, so it's given that each has a cycle time of 20 minutes. So we will see that each has a maximum of time, as each workstation needs to be grouped in such a way that they have a station time of 20 minutes or below. Element, station time, idle time. Now we will write the time duration for each of the activities. 6, 5, 4, 8, 5, 4, 7, 6, 10, 10, 7, 10, 6, 9. Now we will group each of them. Okay. So we will first start with A, B, C, and this will E will become one workstation. Next workstation is D, G, F. Next workstation is I and J. The one more workstation is, we have four workstations. K, L and N, and this is KMH. 5, 4, 3, 1, this is 2. So for each workstation we will write the element A6, B5, E5, C4. Station time is 20. Now for this idle time is 20 minus 20 is equal to 0. Idle time is cycle time minus station time. Cycle time minus station time. For the next workstation we have element is D, 8, G, 7, F4. Station time is 19. This is 20 minus 19 is equal to 1. For the next workstation we have element is I, 10, J, 10. Station time is 20. Idle time is 20 minus 20 is equal to 0. For the next element we have workstation 4 is H6, K7, M6. Total station time is 7 plus 6, 13, 19. Idle time is 1. For the last station, workstation 5 is L, 10, N, 9. Total time, station time is 19. Till time is 1. So with this, we found out the idle time at each workstation and the optimum number of workstations. This is how we balanced it, and the optimum number of workstation is 5. Okay, so next question. Cranes are material handling equipment used for which of the following? Now here one more thing I would like to add with the previous question is that now here the total work duration of all the tasks is equal to 97 minutes. Cycle time is 20 minutes. Number of workstations is equal to 97 by 20 is equal to 4.85. So optimal number of workstations is equal to 5. This is the method in which we find out the workstations. So we found out the ideal time at each workstation, optimum number of workstation, we found the balancing, we balance the assembly line. Okay. Now the next question. Cranes are material handling equipment used for, okay, we discussed this in our previous that it is a it can be used for vertical transportation, short distance transportation, lifting and lowering. We discussed this concept in our first question itself, where we discussed on the material handling equipment, continuous in movement, interrupted movement, and later we discussed here in this part where we discussed on hoisting machine, forklift, chutes. Effectiveness of material handling system can be measured by the ratio of effective of material handling system can be measured using the kind of time spent in material handling. So this is time spent in material handling to the total production time. So what happens is here the time applied in the material handling or we can say the time required to move the material is divided by the total time to produce. Okay, like this also can be said as or time required to move the material. This is the effectiveness. So suppose total time is equal to 60 minutes. Total time is equal to 60 minutes and time required to move is equal to 40 minutes. That means effectiveness is equal to 40 by 60. So in this means we invest a lot of time in moving the material. That means, so how much percentage of the time efforts are made in moving the material out of the total production time. So this is one parameter, like the time required to in process of the material handling or for the process of material handling divided by total time required for production. So ratio of the time spent in material handling to the total time of production. That means how much percentage of the time efforts are made in moving the material out of the total production time. Okay, this is about the effectiveness. Now the next question. The objectives of production planning and control are achieving required satisfaction level of customers, coordinating with multiple departments to ensure that the production is on track, delivery of goods and services on time, all of these. In totality, production planning and control helps in developing the plans in such a way that the required resources are arranged, and using those resources, the things are produced in such a way that they are of required quality, quantity, things are produced in time, that at a very low cost, so that organization can provide the quality products to their customers at a very competitive price. That means these all of the options are correct. So production PPC, production planning control, required resources are arranged, using those resources the things are produced in such a way that they are of required quality, quantity, things are produced in things are produced in time, and that too at a very low cost. This is the objective of production quality. The main aim is the organization can provide the quality products to their customers at a very competitive price. Okay. So the next question. Aggregate planning is a method to make the decision for. Okay. So we discussed again about aggregate planning. This is one more question. So aggregate planning, this acts as an input for the production system. For the production system, identifying, like, it helps in identifying the kind of the labor material or capital which will be needed for a smooth production. So this is the intermediate kind of planning which is done for a period of 3 months to 12 months. When the number of components which are being produced, like what will be the components that will be needed, those will be identified in this stage. So the planning of this quantity and timing when the different subcomponents will be needed, that is identified. So it also considers like what is identified, what demand is there, what is the fluctuation in demand, how this fluctuation in demand will be met through the labor adjustments or through the inventory. Such kind of planning helps in minimizing the cost. So, so overall, this acts as an input for the production system. So it involves all these parameters: inventory, production rate, number of workers to be committed. So suppose we strategies are required to meet the number of units to be produced of the different components at a given time. Various strategies can be followed, like varying the workforce. If more volume is needed, we need to deploy more workers to increase the production using the facilities available. Number of shifts can be increased. If the number of units desired are reduced, then the layoff or firing takes place. So varying the workforce as per the demand is one of the way here. Then adjusting the number of workers, like varying the number of working hours. So for a given stable workforce means for a given number of workers, you can allow the idle time. If the reduction in production is needed, so we can work, suppose for fulfilling extra time, we can work overtime, or if there is an increase in demand or rush order situation, we can work overtime. Thus, aggregate means the fluctuation in demand can be met through the varying variation in the inventory level, or subcontracts can be provided to have the deal with the extra demand. So subcontracting of the work to provide the extra capacity. Okay, so the next question. The flow of material in the plant to different paths is included in a stage is included in which of the stage? Expediting, tool planning, process planning, routing, loading. So we know that the active planning comprises of process planning, routing, material planning, tool planning, loading, scheduling. So, routing is about the flow of work which or the material in the course of production. This means what will be the different stages through which it will be passing, like, or what will be the different paths it will be following, that will depend on the layout of the facility. That will depend on the layout of the facilities. So, in routing, we know the flow of the material in the plant to different paths. Okay, so the next question. The function of production planning and control related to the timeline of activities is, this correct option is scheduling. So, scheduling will tell us the time when the particular work will be done. So, scheduling tells us the time when particular work will be started and finished. It will also tell us the sequence in which the operations will be done. Operation of jobs will be done so that it will be completed in time. It will be completed on time. So, proper scheduling will help in loading the different machines in such a way that they are loaded in balanced way. So, we will be identifying when particular work will be started on a particular facility and when it will be completed. What will be the different sequence of job operations and the job will be done. So, we will be indicating the status of the progress of the work at a particular facility. Okay, this was about scheduling. We discussed about expediting, dispatching, routing earlier also. Now, next is inventory level satisfies the demand of the product when planned capacity is, well, this is equal to the demand or more than the demand. This is obvious. If our inventory is more than the demand or equal to the demand, then only if the planned capacity is more than demand or equal to the demand, then only inventory level can be satisfied. Now next one, routing comes under, well, we know this. Again, the routing comes under active planning. I already said active planning comprises of routing, material planning, tool planning, loading and scheduling. So out of this, routing comes under active planning. Routing is the flow. Routing is very important because routing tells about the flow of work or the material in course of production. This means like what will be the different stages through which it will be passing and what will be the different paths it will be following, that will depend upon the layout of the facilities. Okay, so the next question. Long-term capacity planning is difficult due to uncertainty in, well, short-term capacity planning we read earlier. It was because of some new technology or breakthrough in technology or due to some obsolete technology or some new invention, that was short-term capacity planning. Now, long-term capacity planning is like, which is for long-term capacity planning, which is for 5 to 10 years ahead. Now this becomes very difficult because the future demand, we have to forecast about the future demand, the technological advancement, development. We have to forecast about the future demand, technological development, and forecast for a future in future will be very difficult. And seeing all this and subsequently forecast in future for such a long term is very difficult. So what happens is there will be various uncertainties, whether that kind of technology will prevail for after 5 to 10 years, or that kind of demand will be there, or the kind of forecasting for that long period is very difficult. So because of these uncertainties, the long term strategies is really very difficult, but still some methods are available, and these long term strategies further influenced by that type of product development. So this is the reason why long-term planning is difficult due to uncertainty in future demand, product development, and product life cycle forecast in future. So the correct option is all of these. Okay. So we reached to the end of today's session. So as we know, the major questions were revolving around production planning and control, scheduling, dispatching, routing, long-term production planning, long-term capacity planning, short-term capacity planning, aggregate planning. These are the main topics for this particular session. So, and also we discussed one question on assembly line, how we balance the assembly line. We found that the ideal number of workstations. We found out the idle time, uh, which was cycle time minus the station time. So that was a very important numerical. Okay. So any doubts, you can always ask in announcement time. Thank you for attending the session.